It is human nature to want to understand the world we live in, and scientists are no exception to this. For the last 100 or so years, they have been focusing on the idea of unification. This is the idea that all laws of science can be explained by one overlying law that ties all of them together. A unified theory must tie together all four forces: weak, strong, electromagnetic, and gravitational. In 1919, a physicist named Theodore Kaluza suggested that maybe there were more than three dimensions, the original three being up, down, left, right, and back and forth. In 1926, another scientist, Klein, expanded on this original idea by stating that these dimensions came in two different types. The first type being big and easy to see, and the second type being tiny and all curled up. And the second type is so small that it can't actually be seen. This idea has become known as string theory. This theory states that when you go even further and further past the atoms, the electrons, the quarks, there are tiny strings of vibrating energy, and these vibrations vibrate at different frequencies and make up pretty much everything we see and know. When working through all the math, for string theory to actually work and be true, there'd have to be 10 dimensions of space and 1 dimension of time. At the same time that these ideas were originally being thought of, Einstein was working on his theory regarding gravity, otherwise known as general relativity. It all revolved around the question of how does gravity work? What Einstein found was that matter causes space to warp. Another important theory is quantum mechanics, which deals with physics on an incredibly small scale. Quantum mechanics and general relativity both work individually, but they don't work when you put them together. When you try to scale general relativity down, it doesn't work, and when you try to scale quantum mechanics up, it doesn't work either. General relativity is described as smooth and continuous, while quantum mechanics happens in jumps. String theory is what would bridge the gap between general relativity and quantum mechanics. Physicists are drawn to this theory because it would apply to and work on all scales. It could potentially answer a lot of questions about how our universe works. The key term here being potentially, as string theory has not yet been proven. Who knows? Maybe someone like me will prove string theory as true one